Thank you very much. It is a pleasure being one of the speakers on this conference. So thank you again for the invitation, Bob. And I'm going to try to let you guys understand a bit more about us building a GBS. GBS stands for Gravity-Based Structure. That means when we are done, it will be standing on the bottom out at the Grand Banks. Where do I... Okay, I'm okay. I'm in charge of a joint venture. The joint venture consists of two companies, Kværner from Norway and Kiewit from US. We had the same constellation on Hibernia 20 years ago, so it's good to be back and see some of those that took on the task 20 years ago. Those two companies have quite some task behind them. Kværner have been and been responsible for 25 such GBSs built around the world, and Kiewit have more than 120 years of construction experience. This is the GBS history that was kicked off in the end of 1960. And this is a fantastic business history from Norway, and you guys can copy some of this out on the Grand Banks. And of course, the most challenging one and the most interesting one is the Troll, almost 370 meter high. It is the biggest structure ever moved by human on Earth. So to be a part of that was quite something. But I have to say, being here 20 years ago on Hibernia was also quite something. It was an extremely complex structure and a special environment. You have a bit tougher winter over here than back home in Norway. And today I'm going to talk about the last one on this slide, and that's Hebron. Hebron is located east-southeast from St. John's. And ExxonMobil is the operator, 36%, Chevron, 26.7%, Suncor, 22.7%, Statoil, 9.7%, and Nalcor, 4.9%. This is our concept that we have worked with for more than 8 years to develop for that group. The water depth out on the Grand Banks is 93 meters. The height of the structure is 122 meters, and the width of the GBS is 130. The concrete volume that goes into this is 136,000 cubic meters of concrete. And that's a lot of concrete. And to make sure that this structure outstands icebergs, wind loads, waves, we need a lot of rebar. So there is 41,000 tons of rebar into this structure. But that isn't enough. So we have to add pre-stressed steel. So we stress this concrete in a special way. So there is 3,500 tons of post-tensioning steel into the structure as well. This is the topside. Here you see the GBS together with the topside on. And what I would like to highlight when it's come to the topside is the weight of the topside. The weight of this topside is 65,000 tons. This is the biggest topside ever been put on top of the GBS. So this is an enormous task, and this project today is classified as one of the biggest in the oil and gas industry around the world. And the good stuff with a concept like this is that you can build the GBS and the topside at the same time and then melt them together in the end, and I will show you. I'm really proud to say that we have produced more than 9 million man-hours, person-hours without a serious incident. Our total recordable incident last year was 0.79. Our total recordable incident today is 0.45. And that is a very, very good result. And I will give you a story behind that result that we see today. Last year, we had 2 diamond events. A diamond event is a near miss that will be classified as to have a potential for a fatality. So we had 2 in a very short time frame, and that became a huge issue. So I got a special call from my board. I got a special call from Exxon, and they was definitely not happy with the safety result. I did a reflection, and I have to say I don't like being beaten up, but it's okay to be beaten up if you conclude that you can do better. I concluded that afternoon that I, together with RDTC, could do better. So we joined our forces, and this is a fantastic story, what can happen when you really communicate and dig into a task with all your energy on the both sides of the table. I have to give quite some recognition to RDTC for that task. We decided to meet each one and everyone, and so we did. I'm not quite sure how many meetings we had, but we did it. We did it, and that gave us a fantastic result. This is one piece of paper that David Wade and myself signed back to try to put in place a mission statement. A mission statement is very often a piece of paper that ends up not being used. I can tell you this piece of paper is, for me, important. It is important because it's kicked off a way to communicate. This is a piece of a foundation for building a bridge, meeting on top of that bridge, communicate, making sure that we have an understanding what to do and how to do it. So thank you, David. Thank you, all the members of RDTC for being a part of this mission statement. That means a lot for me. This is a view from Bull Arm. To the right, you see the topside site, and to the left, you see the GBS site. The GBS is built in a dry dock, so there is a bund wall that keeps the ocean out. So the lowest part in that dock is 16 meters below sea level. The topside area, the concrete pier that you see, is there for all the modules from around the world coming in will be placed on that pier. And then the modules will be hooked up, being one topside together. The building you see, the door in that building is the highest door in Canada, 52 meter high. So you can build a module, take that module out and place it on that pier. So it is an impressive site for building a topside and a GBS side by side, being ready at the same time and then melt together. This is a view of the dry dock area. You see the structure with all the cranes down in the dock, and you see the bund wall, and up to the left you see the offices and some buildings. Okay, this is how we build this structure. Underneath the concrete there is steel skirts. There is 60 centimeters with steel skirt that will secure the stability of this structure when we place that down at the Grand Banks. Then we divided the bottom slab into 4 pieces, and there is a lot of concrete and rebar into that foundation. The first slip is the center shaft, and the main reason for us taking the center shaft as the first part is caused by all the mechanical outfitting in the center shaft. So that was the first slip that we kicked off last summer. The next slip was done in August last year. Then we took all the other cells up to 26 meters. I will come back and explain what a slip operation is about. Then there was some walls outside around the GBS that was divided into 4, and that was also a slip form operation with a roof on top. We are now ready to take water into the dock. We are going to fill water in the dock this month, the 23rd, and believe it or not, then this piece of concrete will float. So we are then going to take the structure from the dry dock out to the deep water site area, moor it up, and the first operation at the deep water site will be the biggest slip ever have been undertaken on that island. That slip consists of 1 kilometer with walls, concrete walls. There is 1,000 hydraulic jacks that are going to lift the working platform up step by step. Each lift is 13 millimeters. And I'm going to show you how we are going to do that. That operation will take about 35 days, and it's going to take place this August. We start August the 1st, and we are ending in the beginning of September. The next task is to put the roof on top of all the cells, and then the last piece is the shaft that are going to handle the huge topside. And we will be ready for mating December 2015. This is a couple of pictures that show the civil construction work in the dock. You see here the center shaft, and you see all the cranes that we have today. We have 6 cranes serving all the job on this task. This is from you see the tri-cells. There is 7 tri-cells around the center shaft, and you see the preparation down in the bottom for the slip coming up. This is a picture where you see the caisson walls being taken care of. This is from the center shaft, the mechanical outfitting. There is 8,000 tons of mechanical outfitting in that shaft, so I will show you some picture that I think will impress you. That shaft will be packed with pipes and steel and instruments. This is a picture from Hibernia, the tow out of Hibernia. We are going to follow exactly the same procedure. When we fill water in the dock, we pump water into the structure because we want to control the lift-off. So when we are ready to take the lift-off, then we pump water out from the structure, and it goes, it's float, and then we tow it out to the deep water site area, and there is 9 mooring lines hooked up to the GBS that will make sure that the GBS is in the same position all the time. Around the GBS, there is a flotilla, huge barges. The most important is probably the batch plant. The biggest barge you see is, there is 2 modern batch planters on that barge that give us a constant flow of concrete. There is an access barge. You see the 2 ferries being there, where all the people are coming in and going out. And of course, we have a power barge, and the rest of the barges is mostly rebar and material. And the green line around is the walking. You have to be able to walk around. And this flotilla is, by Transport Canada, classified as a ship. So there is a lot of bits and pieces that need to be put together before they give us a green light to get people on board. You see a picture from the deep water site from Hibernia, and you see a sketch from Hebron at the deep water site. This is how a slip is undertaken. You have the upper working deck, and you have the main working deck and the lower working deck. And you see in the middle here, you see 2 roads going down to the concrete. That is, on top of that, there is a hydraulic jack, and that is, those jacks climbs on those roads, and that is what lifts everything. There is a form sheet that is 1.2 meter high. We fill fresh concrete on top, and when that concrete is coming underneath the form, it is hardened. It's solid, and it's stand itself. So it is a simple way, and it is a perfect way to motivate workers. From the top working deck, we do the vertical rebars, we do the concrete supply, and the main working deck is mostly to make sure that we vibrate and get the concrete in place and the rebar. The lower working deck is to make sure that the finish, all the polish and the finish of the wall is taken care of, and underneath the lower working deck, the quality will have to be in place. This is a picture from a slip. You see those red yokes. You see the vertical that have the steel form, the panels on, and you see the horizontal, and you can, if you can see one of the hydraulic jacks behind the rebar. You see the pipes for the pre-stressing. So when the slip is done, then we push cables through that, and we stress the concrete. Okay, I'm going to let you watch a video. It takes 3 minutes. That is a short sum up of what we have done up until now.
video ever did.
Yeah, it is a special piece of work that have been put in place in the dry dock, and I give the credit to the workers. Very often we forget them. Very often we forget to listen to the most important part of our organization. And that is those people that's wearing overall. They are the one that know exactly what to do. They are the one that see the opportunities. And it's hard to believe that it's so difficult for us being above them to listen and take them into what we are doing. I'm really proud of what we have put it in place up until now. We are about 50% done. We have 2 years left, and I will classify the dry dock area to be the most complex and difficult task, because we are doing detailed design at the same time as we are working, and that gave us sometimes some surprises. Okay, the last piece that we are going to build is the shaft, and what I will this shaft, technically set, is the most difficult shaft we ever have been undertaken. It is so because it goes from a circular diameter to a square on top. So we are going to do that while we are doing the slipform, and that is a special technical issue, and it is a bit more difficult here than what we are used to, caused by the weight of the topside. 62,000 tons is going to be placed on top of that square, and it requires an enormous amount of rebar, making sure that that shaft have the forces to take that piece of steel. You see to the right, the inside the shaft, the mechanical outfitting. There is a lot of pipes, conductor guides, and steel being into that shaft. This is you see here the whole shaft, and those 8,000 tons being put into this is an enormous task for us to look into at the deepwater site. That piece of work will be on the critical part after the big slip being done in August. The rest of the job will be about the mechanical outfitting planning-wise. This is the ultimate test of a GBS. This is, you see here, Hibernia, and what we are doing, we pump water into the structure, take the structure down to the sea until there is only between 6 and 7 meters above sea level. This is the preparation for the deck mating. This is the preparation for us putting the deck on top of it and melt those two construction together. And this is the most critical part. This structure will never ever see those forces that the structure will see when we do this operation. This is the top side, so from Hibernia. All the modules have been lifted off the pier, the concrete pier that we saw from the topside area. All modules have been hooked together, and then 2 enormous barges will be filled with water taking down underneath the topside, and then pump water out from the barges, it lifted then the topside off the pier, and we tow it out to the deep water site above the GBS. We then pump water out from the GBS. It is a simple mechanism. It is about water in and out. And we lift the GBS until we touch it, and there is 42 bolts that have to fit into the hole, and that's the critical part of that operation. So if everything is in place, and it will be, then we continue to pump water out from the GBS, and we lift that 65,000 ton of topside up, and it will look like this. So we then have a 30 meter from the lowest part of the topside and down to the sea level, there will be around 30 meters. This is a picture from us preparing for the tow to field and the installation. So there is a high number of tugs being around, being ready to tow the structure and do the installation out at Grand Banks. Here you see the positioning of the tugs, and this Hibernia is here ready to be settled down at the bottom. Then you have all the tugs around making sure that we hit exact the point that we need to hit. This is for us an enormous task to undertake. There is one thing that we definitely want to put high up on the agenda. We have listed 4 important values that we put a lot of energy into, and the first one is being safe. The second one is being ready for mating, 15, 12, 15. The third one is doing right. We have to make sure that all the documentation is well taken care of, because in the end, we get the stamp from Exxon, fit for use, and then we tow it. And in the end, lowest possible cost. What I will see in the future, I will see a group of people really coming together, fixed what needs to be fixed. And again, I say thank you to RDTC, being the one you are, helping us out with all those issues that we see. And I look forward to continue to work with you and making sure that we have the right craft doing their job. Thank you for your attention.